Right now you are tethered. Your chair holds you against gravity. Your screen binds your attention. Your identity, your sense of I am, is a tethered ensemble of memories, values, and biology. 400 years ago, Galileo discovered that tethering is not a limitation. It is the enabler of all identity. This is principle alpha. Now imagine a rope. It joins two bodies. On one end, a heavy block. On the other, a lighter block. Drop them together off a tower, not separately, but tethered. Aristotle said the heavy block would drag the light one downward, making the pair fall faster than the heavy block alone. But that makes no sense. The light block would slow the pair down. So the pair should fall slower than the heavy block alone. The pair cannot fall both faster and slower than the heavy block. One of these must be wrong. 400 years ago, Galileo noticed this contradiction, and when he yanked on that logical thread, the entire edifice of Aristotelian physics unraveled. But here is what historians have missed. Galileo did not merely find a clever logical trick to destroy an old theory. He discovered something far deeper, a principle about how the universe actually works, a principle about tethering. And that principle, refined and extended, is the foundation of everything we are about to discuss. This is principle alpha. When we talk about a tether, a rope, a bond, a connection, we usually imagine restriction, chains, bondage, a constraint that limits what you can do. But Galileo found something paradoxical. The tether does something unexpected. It works in two opposite modes. First, the negative mode, where logic is a weapon. In Galileo's time, Discorsi e dimostrazioni matematiche, the famous book that summarized his life's work, he used the tether as a logical weapon, a reductio ad absurdum. Here is how it works. You have two bodies, call them A and B. Suppose they are made of the same material, say lead. Aristotle claims that heavier bodies fall faster than lighter bodies. So, A, being heavier, falls faster than B. Now tether them together with a rope. You have created a composite system. Aristotle's logic says the composite system is heavier than A alone, so it should fall faster than A. But the composite system contains B, which is lighter and falls slower. So B should retard A, making the pair fall slower than A. These cannot both be true. A thing cannot fall both faster and slower than itself. The contradiction is unavoidable unless Aristotle was wrong, unless heavy and light bodies fall at the same speed, regardless of weight. The rope, the tether, served as a logical trap. It forced the contradiction to the surface. This is the negative mode of the tether. It destroys. It reveals contradiction. It says, your assumption leads to logical impossibility. Abandon it. We move to the positive mode and mechanism as an enabler. But there is a fragment, buried at the very end of I.E. Drabkin's 1960 translation, in the final pages of the final appendix. It is a memorandum written between De Motu and Le Mécanique. Galileo writes, lighter bodies move easily so long as they are joined to the mover. This is the birth of the positive mode. The tether is no longer a rope that restricts, it is a mechanism that allows the part to ride the inertia of the whole. Notice the word, easily. Not faster, not slower. Easily. This is a completely different statement than the logical trap. This is not Galileo destroying Aristotle. This is Galileo describing something he has observed, something positive. When a lighter body is tethered to a mover, when they are physically joined, the lighter body moves with less resistance. It moves as if the work of moving it has become easier for the system. This is remarkable. The tether is not a constraint that imposes resistance. It is a mechanism that enables capacity. Think about it practically. Imagine you are trying to move a heavy block across rough ground. It is difficult. It resists. But now imagine that same block is attached, tethered, to a much larger, heavier block. When the larger block moves, it drags the smaller one along. The smaller block moves effortlessly relative to the ground because it is now part of a larger system that has the power to overcome the resistance. The lighter body moves easily because it has been joined to the mover. It no longer fights the ground alone. It rides the inertia of the larger system. This is the positive mode of the tether. It enables. It creates capacity. It says, by joining these disparate things, we create something neither could achieve alone. Here is what makes this discovery revolutionary. Galileo realized that the tether was more fundamental than the properties of the things being tethered. In Aristotelian philosophy, things have essences. A heavy body has the essence of heaviness. A light body has the essence of lightness. These are inherent qualities, independent of anything else. But when you tether a heavy and a light body together, something strange happens. The light body loses its lightness. The heavy body loses its heaviness. What emerges from the tether is something entirely new, a unified system with its own behavior. The behavior of the pair is not the sum of the behaviors of the individuals. A light body falls slowly, a heavy body falls fast. But a tethered light and heavy body fall together at the same speed. Not a compromise between the two, but a unified trajectory determined by the system as a whole. This is profound. It says, system identity supersedes component nature. What the tether does is simple. It removes the independence of the parts. It forces them to move together. But in doing so, it creates something that did not exist before. A unified identity with its own rules, its own behavior. The tether is not just a physical rope. It is an ontological principle. It is a statement about what is real. Before the tether, two separate substances, each with its own nature. After the tether, one unified system, transcending the natures of its parts. Galileo grasped this, though he did not have modern language to express it. In De Motu, he writes of the tether as if it were almost magical, a tool that transforms not just the motion of bodies, but the very identity of what is moving. Across his life, Galileo's understanding of the tether evolved. It started as a physical rope. It became, by the end, an invisible mathematical law binding all bodies in the cosmos to uniform gravitational acceleration. In Discorsi, he almost never mentions the rope explicitly. The tether has become the entire conceptual framework. It is gravity. It is inertia. It is the constraint that forces the universe to obey mathematical law. Let us trace this evolution, because it reveals something essential about how tethering works. In De Motu, Galileo is still a young scholar, still thinking in terms of physical objects and mechanical action. The tether is a rope, a literally physical thing. Two bodies are joined by rope. The rope has tension. This tension pulls on both bodies equally and opposite, action and reaction. The rope forces them to move as one unit. At this stage, the tether is clearly a mechanism. It is how the unification happens. The rope physically constrains the relative motion of the two bodies. They cannot move apart because the rope would break, or they would have to break it. This is empirical, observable. You can see the rope. You can measure the tension in it. But even here, Galileo senses something deeper. He uses the tether not just to describe motion, but to solve problems. He uses the tether as a conceptual tool to understand systems he cannot directly observe, like the behavior of a floating chip in water, or the dynamics of falling bodies in a resisting medium. In his Postules to Rocco, written around 1634, Galileo returns to the tether question. He begins to strip away the idea of essential weight. By referencing the Drabkin fragments previously mentioned, we see Galileo realizing that weight is not an inherent property, but a relational one, an emergent resistance to a constraint. He is older now, more careful. He refines the concept. He realizes that the tether does something subtle. It creates mutual action-reaction without net speed gain. When you tether two bodies, They do not change their combined speed relative to an external observer, but internally, the tether creates forces. The light body experiences an upward pull from the tether. The heavy body experiences a downward pull. These forces are equal and opposite. They cancel out in the sense that they create no net acceleration of the system as a whole, but they create something else, a unified constraint structure. Galileo makes a distinction that is crucial, the difference between static weight and dynamic weight. A body sitting on a scale has static weight. It presses down with a certain force. But that force is not what causes it to fall. When a body is in free fall, its weight plays no role in its acceleration. Being weighed down, Galileo writes, is opposition to a descending body. Without something resisting the descent, there is no weight. Weight is not an inherent property of the body. It is a relational property, emerging from interaction with an external constraint. This is another subtle revolution in thinking. Properties are not inherent. They are relational. They emerge from tethering. By discorsi, Galileo's thinking has reached its apex. The physical rope has vanished. What remains is the principle. All bodies in the universe are tethered to something, not by ropes, but by mathematical law. Universal gravitation binds all bodies to the earth. Inertia binds all bodies to their current state of motion. The universe is one vast web of constraints, tethers, that force disparate things to move according to mathematical pattern. Gravity is a tether. Electromagnetism is a tether. All the forces of nature are tethers, binding bodies together into coherent systems that follow law. And the most profound tether of all is mathematics itself, the invisible constraint that forces reality to conform to ratio and proportion. Galileo never used the word tether in his mature works. He did not need to. The concept had sublimated. It had become the very foundation of his natural philosophy. The physical rope was merely the gateway. The real insight was this: the universe is constituted by relations, not by things, and tethers are the mechanism by which relations are enforced. Now we need to address something that Galileo intuited but could not fully articulate, something that modern physics has gotten fundamentally wrong. For the past century, physicists have been obsessed with symmetry. The universe is symmetric under parity. It is symmetric under charge conjugation. It is symmetric under time reversal. Symmetry is beautiful. Symmetry is powerful. Symmetry is true. Except it is not. In 1956, two physicists named Tsung-Dao Lee and Chen-Ning Yang did something audacious. They challenged the sacred symmetry assumption. They asked, what if parity symmetry is actually violated in nature? The theoretical community was appalled, but they were right. Within months, Qian-Xiong Wu conducted the experiment. She observed the decay of cobalt-60 nuclei and found something shocking. The particles preferred a specific handedness. They were not symmetric. The universe has a chirality, a handedness baked into its foundations. Then, in 1964, James Cronin and Val Fitch discovered that CP symmetry is violated too. Matter and antimatter are not symmetric. The universe distinguishes between them at the quantum level. The Standard Model's response was to invent more symmetries to explain why the old symmetries are broken. CPT symmetry, electroweak symmetry breaking, supersymmetry, still unobserved but theoretically necessary to preserve the symmetry doctrine. This is backward. This is defending a failed premise by multiplying hypotheses. The corrected view. Nature is fundamentally asymmetrical. Symmetries are not foundational. They are emergent statistical properties. When you average over many asymmetrical microstates, symmetry emerges. But the foundation is asymmetry. And this is where the tether becomes essential. The tether is the mechanism by which local asymmetries resist entropy and achieve coherent persistence. Think about a river flowing downhill. The water molecules are constantly bumping into each other, moving randomly. Yet the river has a flow. It has direction. It has chirality. It spirals as it descends. Why? Because the riverbed constrains the motion. The tether of gravity pulls all that water downward. The tether of friction with the banks channels the flow. The result is an organized pattern emerging from random components. This is not symmetry. This is asymmetry organized by constraint. The tether works because nature is asymmetrical. If nature were fundamentally symmetric, if all microstates were equally likely, if there were no preference for one direction over another, then tethers would not work. Random motion would erase any organized pattern immediately. But nature is asymmetrical. There is a preferred direction, there is chirality, there is a flow. And the tether is what captures that asymmetry and converts it into coherent identity. Let us step back and ask, what is principle alpha really saying? At the deepest level, it is a claim about what exists. The Aristotelian view is that substances are fundamental. A thing has properties because of its essential nature. A stone is heavy because heaviness is part of its substance. But Galileo discovered that relations are fundamental. A thing behaves as it does not because of inherent essence, but because of how it is tethered to other things and to the universe itself. This is a shift from a substance ontology to a relational ontology. In a substance ontology, the universe is a collection of independent things, each with its own nature. They interact, but the interaction is secondary. The primary reality is the substance. In a relational ontology, the universe is a web of relations. Identity is not primary. Differentiation from other is primary. You are what you are only insofar as you are tethered to and differentiated from the rest of the cosmos. The tether is the instrument of differentiation. It draws a boundary. It says, this ensemble of parts bound together by constraint constitutes a unified identity. Everything outside that boundary is other. Consciousness, in this view, is simply the highest expression of this relational principle. A conscious system is one that has developed such tight, intricate tethers, both to its own parts and to its environment, that it can represent and respond to the structure of those relations. We will explore this in later episodes, but the core insight must be clear. Principle alpha states that system identity, the very fact of being a unified, distinct thing, is constituted by tethering. Without tethers, there is no differentiation. There is only an undifferentiated thermodynamic soup. With tethers, reality achieves structure, identity, and the possibility of meaning. If this insight is so profound, why did it disappear from the history of physics? The answer is methodological. After Galileo, physics became increasingly focused on forces. Newton invented the calculus and reformulated Galileo's insights in terms of forces, masses, and accelerations. The tether concept evaporated. In its place came the equation F equals ma. This was enormously powerful. The force formulation allowed physicists to calculate trajectories, predict planetary motion, design machines. It worked. But it obscured the underlying principle. When you focus on force, you treat the constraint as external, something applied to the system to change its motion. You lose sight of the tether as a constitutive principle of identity. Over the centuries, this externalist view of constraint became dogma. Constraints were treated as limitations, friction, air resistance, obstacles. Good physics was about systems with no constraints, moving freely in empty space. When constraints reappeared in 20th century physics, they came back in new languages. Holonomic constraints in Lagrangian mechanics, gauge symmetries in quantum field theory, curvature in general relativity. These are all expressions of tethering, but they are no longer called tethers. They are fragmented into technical jargon, domain-specific vocabularies that hide their common nature. We have split and mathematicized the tether into specialized compartments, losing sight of the conceptual why in the pursuit of the how. And in doing so, we have also lost Galileo's original insight. The tether is ontologically fundamental. It is not something external to the system, it is what makes the system a system. To make this concrete, let us see where tethering appears in modern science, hidden under different names. First, in physics as constraints and conserved quantities. In classical mechanics, we use Lagrangian formalism. This is a mathematical framework that assumes a system has a Lagrangian, a function that encodes the system's kinetic and potential energy. When we impose a constraint, say that two bodies must remain a fixed distance apart, we introduce a Lagrange multiplier. This multiplier is a kind of hidden force that enforces the constraint without needing to know explicitly what the force is. This is the tether in modern dress. The Lagrange multiplier is the mathematical agent of constraint. It is invisible, but it is the hidden hand that forces the system to behave as unified identity. Now in biology as metabolic coupling, a cell is alive because it maintains tight constraints on its internal environment. Membranes tether the interior of the cell to its own chemistry, separate from the outside world. Within the cell, metabolic networks create chemical tethers, pathways of enzymatic reaction that bind the chemistry of the cell into a coherent, coordinated system. Without these tethers, the cell would be just a random chemical reaction. With them, it becomes a living entity with identity and purpose. Then, in ecology, we have the predator-prey dynamics. An ecosystem is stable not because things are in equilibrium, but because tethers bind the population dynamics. Predators are tethered to their prey. The population of predators rises and falls in response to prey abundance. The prey is tethered to its food source. The result is stable oscillation, not equilibrium, but a dynamical pattern that persists. Remove the tether, say hunt the predators to extinction, and the system collapses. The prey explodes in population, devours all available resources, and crashes. The ecosystem loses coherence. Finally, society's norms and institutions. Human societies are tethered by shared norms, institutions, and ideologies. These are the social tethers. When tethers are strong, the society is coherent. People understand their roles, their identities, their relationships to others. Society functions. When tethers are weak or broken, society fragments. People lose identity. Chaos emerges. This is why revolutions are so dangerous. They sever the old tethers without establishing new ones. In the vacuum, anything can happen. What does this mean? Why does it matter that we rediscover and articulate principle alpha? First, it gives us a unified conceptual framework for understanding vastly different phenomena. From falling bodies to living cells to human consciousness to ecosystems, the same principle operates. Identity requires tethering. Second, it corrects a fundamental bias in modern science. We have been so focused on studying free systems, particles in vacuum, idealized objects with no friction, isolated systems, that we have missed the most important fact. Nothing in nature is free. Everything is tethered. Everything is constrained. Third, it opens a path to understanding emergence and complexity. Why do simple components organized by simple rules give rise to complex, intelligent systems? Because the tethers allow organization to accumulate and persist. Because constraints, properly arranged, do not limit capability, they enable it. And finally, it restores philosophy to its rightful place in physics. We cannot understand nature by equations alone. We need concepts. We need to ask, what must be true for mechanism to operate this way? What is the nature of identity? What is the relationship between parts and wholes? Galileo was doing both, mechanism and metaphysics, at the same time. The tether was simultaneously a physical rope and an ontological principle. This is natural philosophy, the investigation of the how and the why as inseparable aspects of understanding reality. We have fragmented this unity into separate disciplines, but Principle Alpha demands we reunite them. The rope that Galileo imagined 400 years ago, binding two falling bodies, was not a mere mechanical tool. It was a window into the nature of existence itself. That window revealed something astonishing. Reality is constituted by relations. Things do not exist in isolation. They exist only insofar as they are tethered, bound by constraint, to the rest of the cosmos. And consciousness, at the highest level, is simply the deepest expression of this relational principle. The ability to represent and honor the tethers that bind us to each other and to the universe. In the episodes to come, we will see how this principle, that system identity supersedes component nature, generates the frameworks for understanding momentum, angular momentum, environmental impedance, and ultimately, the nature of consciousness itself. But the foundation is Galileo's rope. Remember it.